designed to take the heat, the kind caused by the most radioactive of wastes, used nuclear fuel. These fuel rods are too dangerous to be casually disposed of, but encased in special spent fuel canisters, the risks should be contained. Nuclear waste sits in a holding pattern, and that means storing it in massive cylinders until there's a way to dispose of it. These containers start with a big rectangular sheet of stainless steel. A special circular cutter carves a beveled edge onto it. They feed it to rollers, which curl the sheet into a cylinder. It takes 4 trips through the rollers to really round it out. They tuck a template inside the curve to check the radius. Next, a welder joins the neatly beveled edges to complete the cylinder. This cylinder will be the outer wall of a canister. The canister will fit inside a bigger cylinder called an overpack. Its outer shell is 2.5 centimeters thick, about the diameter of an American quarter. Building a container to hold used nuclear fuel is a many-layered process. The next step involves the lid, made of multiple steel discs, with concrete placed between the steel layers like a sandwich. Incredibly, high-pressure water jets easily cut through the thick steel to produce the discs. A computerized tool cuts a grooved profile along the edge of each disc. They also machine the top of each disc to the correct profile and then measure to confirm it's exactly right. Next, a computerized laser slices through more stainless steel plating to produce long, narrow panels. Each is designed to fit together to create a grid of storage cells inside the canister. They line each panel with an aluminum alloy that's neutron absorbent, and they place a piece of steel sheathing on top of that. They weld the steel sheathing to the steel panel, encasing the neutron-absorbent material. Working within a metal framework for guidance, they weld 4 of the lined steel panels together to create a fuel cell grid for one used nuclear fuel bundle. They then build a 68-cell grid. With that complete, they're ready to piece together all the parts of the spent fuel canister. They first lower the inner shell onto the base plate. The shell is held steady by a supportive structure as they weld it together at the seams. Moving inside, they install numerous bars to support the fuel cell grid. With the canister now wrapped in plastic to keep it clean, an automated cutter gradually shaves down the rim to trim it to the correct height. Precision is everything. Using a level and a laser, they ensure that the trim job is even and exact. Once they're satisfied, a crane carries the fuel cell assembly over to the canister and then suspends it above the open cavity. It dangles briefly as workers inspect the assembly. They give it the thumbs up, and the crane then lowers the fuel cell assembly into the cylinder. It's a snug fit, with just over a centimeter of clearance between the inner assembly and the wall of the cylinder. This technician inserts a camera into each cell of the grid and scrutinizes the image. He's looking for any debris that could hamper the installation of the nuclear fuel bundles. Both the cylinder and the fuel cells have been meticulously cleaned, but the camera inspection confirms they haven't missed anything. It's time to put a lid on this nuclear waste canister. It's a trial fit. The lid will be permanently welded to the canister later, once the used fuel rods are safely inside. The canister will then be placed inside the overpack, with concrete poured between the walls. That should keep the hazards of nuclear waste entombed indefinitely.